Hello and welcome back to Maths with Mitch. Today we are factorising quadratics by inspection. So we're going to take a quadratic in the form ax squared plus bx plus c and then change it to two brackets opposite to how we expanded the brackets previously. So let's just have a think about what we did last time in terms of expanding brackets and then consider it in the opposite way. So previously we said if we had two brackets, and we can use the example x minus 1 x plus 2. Then we said if we were going to expand them out, we need to times all the terms by each other, like so. So we can take x times x, it's going to give us x squared. X times plus 2 is going to give us plus 2x. We then have a negative 1 times x, so that's 1x or minus x. And then minus 2 and minus 1 times plus 2, which is minus 2. And then we can neaten that up and say x squared, then have a positive 2x and a negative x, so that's plus x minus 2. So that would then give our rearranged equation, and if we say that was equal to y, that would give our equation once we've expanded the brackets. But what about a scenario when we want to go the opposite direction? We want to get it into brackets rather than in its quadratic form, and that might be very useful for when we're trying to find roots of the equation and values for x and y. So let's consider it in the opposite direction, and this is going to be the method by inspection, which is one way in which you can factorize a quadratic. So firstly, what we want to consider is that we want to get it in the form where we have what we had before as the quadratic with the a, b, and c values. Now, what I want you to consider is we have a term here in front of the x, and then we have this term. And by inspection, we can think about numbers that are going to times together to create this term, and the same numbers we want to be adding together to make this term. And that is purely by the way in which we've expanded those brackets. So if we were to think of numbers that we could times together to make minus 2, we could have a minus 1 and a plus 2, or minus 2 and a plus 1. There's nothing else that are going to times together to make negative 2. There's only those two variations. So once you've thought about which numbers you can have as multiples to make this term, we then want to think about when they add together, what is going to make this term. Now this is a positive 1, remember, so we need to think of positive 1. So here we have negative 1 and positive 2, so that would give a positive 1. So that is probably the what we want, but we'll just check that we don't have the same in the next term. So we have a negative 2 and a positive 1, so that would give a negative 1. So we want a positive 1, we've got a positive 1 here, so this is what we're going to use. So then that means we can split the equation just as we saw before. So we have our x squared term, and we could say we'll then have a minus 1x. We'll then have a plus 2x, and we've still got this minus 2 term. And from there, you can then see that the brackets that we're going to put it into, if you were to consider that this is the mid step of timesing the bracket out, but if you were to take an x out, you would have a negative 1x here. And in the other one, in terms of how you would have created this plus 2x term, you would have had an x and then the plus 2. Because when that times there, you've got a plus 2x, and that x times by this one, you have a negative x. And then again, negative 1 times positive 2 is going to give you the negative 2. So that's the steps we're going to go through. We're going to see what multiples we've got. We're going to see which of them add to give this b number. We'll then do this mid step, because that's going to help us if we've got coefficients of the x squared term that aren't 1, which we'll look at in the next video. And then we're going to move to the next step of putting those into brackets. And again, that would be your y term, and then we'll look at the end of the video what we could use that for with regards to setting y to 0. So let's have a look at another example. Y equals x squared minus x minus 12. And we want to do the same thing. We want to get it into two brackets in the same form of x plus a number and x plus number. Now that might be minus a number, but just in a general form. So again, we're going to look at this term first here, this minus 12, and think which numbers can we times together to make minus 12. So let's start with minus 1 and 12, and the opposite will probably be true. We can also have minus 2 and 6, or minus 6 and positive 2, minus 3 and 4, or minus 4 and 3. They're all going to times together to give negative 12. So next we want to look at what we have this term. Again, we have a 1 in front of there, a minus 1 this time. So let's think about what these add together. Now, of course, you don't have to write it out all of this step every time, but just to be clear, minus 1 plus 12, that's going to give us 11. Minus 12 and 1, minus 11. So there, we've got our answer, haven't we? We wanted a negative 1, and that's exactly what we've got here. So we've got multiples, which will times together to make this minus 12. And we've also got numbers that will add together to give this minus 1. So again, we go through the next step. We have the x squared term, and then we can split it out into these numbers that we've got here. So minus 4x plus 3x minus 12. And then because we've only got a 1 as the coefficient here, it's very easy to then see the next step is x, and then use these terms in front of the x values. So x minus 4, x plus 3. And that's going to give your answer once you've factorized it into brackets. So let's do one last example. Here we've got y equals x squared plus 3x minus 10, and we're going to follow the same steps. So follow the methodology and you'll never go wrong. So firstly, let's look at the minus 10. So what numbers have we got that times together to give minus 10? Minus 1, 10, minus 10, 1, minus 2, 5, positive 2, negative 5. And that's everything. There's no other whole integers that are going to times together to make minus 10. Next step, add them, see what we get, and then think, what is our term here? We wanted a positive 3. Do we have a positive 3? Yes, we do. Therefore, these are the numbers that we're going to use. So we can then say y is x squared plus 5x minus 2x minus 10. Doesn't matter which way around they go because they're going to times together at the end, so it doesn't really matter. You're going to put them in two brackets. Doesn't matter which way around the bracket is. And then we can split that into the brackets. X plus 5, and then x minus 2. So again, exact same steps for following the inspection method. So when you've got a quadratic that can be split into integers, and you've got a coefficient in front of x squared, which is just 1. You can follow the similar method, but it's got an extra step in when we have a coefficient of greater than 1. You can look at that in the next video. So I want to just think about what that now means, what you can do with it. So if we were to pick this example here, what we can now do is find some roots of an equation. So if we were to set y to 0, so if we were to say y equals 0, we know the rule that if anything times's by 0, then the answer is 0. So one method of thinking about this is you've got two brackets where the sum of those brackets that you're going to times them together. So either x plus 5 equals 0 or x minus 2 equals 0. Because if one of these brackets equals 0, doesn't matter what the value is here, that times 0 is going to give you the answer 0. Likewise, the other way around, if you were to make this bracket here 0, times it by whatever the result is here, your y value will be 0. So those two, when y equals 0, these two equations are going to be true. We can then solve. So we want to solve for x, so x and so on. So here we're going to minus 5 from this side and a minus 5 from this side. So that would give us x equals minus 5. And here the same thing, solve for x. So we're going to get rid of the negative 2, want to plus 2 to each side. So we'll say x equals 2. And what that does is give us two coordinate points on a graph, you can think about it. So you have now, here is minus 5, 0, because you said it was when y equals 0, and here is 2, 0. Now you'll recall when we were sketching quadratics that the shape of a quadratic, so something with the x squared term in, is a U shape when x squared is positive. So in terms of a quick sketch of what that number is giving you and what that actually means, you specify that y equals 0. Now, of course, what we're saying there is here, y equals 0 along this line here. That means that's the point at which the graph crosses the x-axis. And you've just defined there and solved two locations. So you've said here, 2, 0, and you've said here, minus 5, 0. Now this is just a sketch, so it's not going to give you the exact points of all the graphs, but essentially you have a quadratic which is in this general shape, and what you solved is the two roots of the quadratic, so the point at which it crosses the x-axis and the value of y equals 0. And that's going to be incredibly useful as you move forward. So that was factorizing quadratic equations using the inspection method. Thank you very much for watching. If you enjoyed today's content, please subscribe to the channel. Join me next time to look at factorizing quadratics, where the coefficient of the x squared term is greater than 1. Thank you very much for watching.